All right, let's continue with this idea of our displacement. So if we were to rewrite this out, we know that R2 is going to be in unit vector notation. All right, we have X, and I'm going to put a sub 2 to indicate that we're talking about the final position vector, kind of where we ended up. So we have X2 in the I, plus Y2 in the, go ahead and say it, J, plus we also have Z, okay, and it's Z sub 2. So we now have R2 represented with this vector, unit vector notation, minus. So R1, we're going to end up with X1 in the I, plus Y1 in the J, plus Z1 in the K. And now we have represented R1. So let's subtract these. Well, you know when we subtract things or add, don't we always add the things that are in the same line? So for example, the X2 and the X1 kind of go together because isn't that the movement in the X direction? So we have X2 minus X1. And we know that that's going to be in the I direction. Plus, now we have Y2 and Y1. Let's subtract those. So Y2 minus Y1. We know that's in the J direction. Z2 minus Z1. And we know that's in the K direction. Well, we know that X2 and X1, aren't those our old friends, the old positions that we used to use last year? We used to call that the change in X. So instead of writing X2 minus X1, let me write that. So I've got the change in X in the I, plus the change in the Y in the J, plus the change in the Z in the K. What does this all equal? This tells us the change in our position vector.